Hello everyone, and today we are going to review how receiving yards from each of the 422 unique receivers and 32,445 unique wide receiver completions correlate to receiving yards. And this is in a data set from 2021 through 2025. So as you can see, many of the receptions from 2021 to 2025 were in the lower numerical columns, so like 4, 6, 8, 10 were some of the most common, and then you go less common as you get larger beyond 6. And then once you get down to 50, you get well below 100 of those receptions for the entire 5-year span. And then receiving yards by quarter, this would be for an individual wide receiver. The most in the first quarter is 98, the least is -8. And then the most in the second quarter is 97, least is -10. Most in the third quarter is 98, least is -11. Most in the fourth quarter is 88, least is -13. And then the most in overtime is 58, with the least being -4. So we started with 38 independent variables, and then by removing the zero variance columns, there were 5 independent variables removed. And then after running a baseline ordinary least squares regression, there were 4 independent variables removed. And then finally, after running a VIF test, I removed all of the variables with a VIF greater than 5, and there were 12 of them. This therefore led to 17 retained independent variables. And there were no independent variables moved due to the Bruch-Pagan test and the White test showing heteroscedasticity. And the optimal K value based on the silhouette method ended up being 3, and the optimal K value based on the gap test ended up being 1. All right. Apologies, this is taking a while to load. So, after doing the Bruch-Pagan test, as you can see, VP value of 53, 29 degrees of freedom, p-value well below the 0.05 threshold, and then the White test always brings back a lower VP value, a lower degrees of freedom, and a lower p-value, showing that heteroscedasticity is present in both tests. So the percentage change in standard error for all of these variables is pretty varied. So replayer challenge went up a lot, QB hit went down, error WPA went up a lot, Vegas win probability down, win probability added over 100%, and then estimated points added went up over 400%. And then if we show more entries, let's go up to 50 as the max because that is more than how many we have. So now we go to, oh my goodness. So now when we see, go down a little further, another stat, quarterback estimated points added went up over 200%, and then of the stats that went down a ton, QB hit down 79, and then goal to go went down 68% as well. Then when testing for multicollinearity, we saw the VIF value of all of these independent variables, and we dropped the 12 that were above 5 and kept the 17 below 5. And as you can see, many of them were closer to 1 than 5, and then you have some that were a little higher, 2 2.2, 2.6, 3.3, and then you get to the ones that were a little close to being dropped, which were first downs, and then definitely the two closest ones were expected yards after catch for success and expected yards after catch for first down. Now we go to the cluster selection. So, according to the elbow method, the graph flattens once you hit 2, even though the K selected here is 3. That was default based on the silhouette method, which is where we found the K value of 3 at the highest point in the graph. And then the optimal value in the gap test was 1, as this is also the highest point in the gap test graph. And then when you see there are 3 clusters, cluster 2 and cluster 3 kind of fall into the same category, and then cluster 1 seems to be more separate by itself. However, I believe that based on these 3 tests, the optimal K should actually be 2. And then once you apply this K, you'll see the elbow method will have it shift over to 2, and now there will be 2 clusters, and it looks a lot more separate, and it looks a lot cleaner in my opinion. So I think 2 clusters is the best way to analyze this data set. And then once you look at the final model, the R squared and adjusted R squared are 0.693, showing 69.3% accuracy in the data, and then 5.99 yards is the RMSE. So when we look at the estimates, so goal to go has a negative estimate with a p-value of 0. Yards after catch has a positive estimate with a p-value of 0, as does WPA, win probability added. Vegas win probability has a negative estimate with a p-value of 0. Quarterback hits has a positive estimate with a p-value of 0. Replayer challenge, positive estimate with a p-value of 0. Drive and play count, negative estimate with a p-value of 0. Drive ended with a score, positive, p-value of 0. Success, negative estimate with a p-value of 0. Expected yards after catch success rate has a positive estimate with a p-value of 0 as well. And then expected yards after catch for first downs, positive, p-value of 0. Expected pass has a positive estimate, p-value of 0. Cluster number 2 has a positive estimate with a p-value of 0 when using cluster 1 as a default variable. And we have first down with a positive estimate with a p-value of 0.0048. And we have the week with a negative estimate and a p-value of 0.0124. So we highlighted all p-values above 0.05, even though many times we consider 10% the threshold for statistical significance. Considering how many of these variables are below 5%, I would believe 5% is a more accurate estimate based on the fact that 15 of the 18 variables fall below the 5% significance level. And then air win probability added still falls below the 10% significance level at 0.90918. And then the total line, which is the total points for the game, estimate is 0.134. And then a divisional game has a correlation of 0.1666. So all of these have pretty decent significance. However, 16 of 18 fall into the statistically significant category of 10% or better, and 15 of 18 fall into the statistically significant category of 5% or better. And then when you go even further, we go to how many? We got 1, 2, 3, 4, 5. We got 13 variables with a p-value of 0, and that goes 4 decimal points. And then we can explore the players in each cluster. So we can say, what season do we want to look at? We can look at 2025 only. And then we could look at, say, only the receptions that fell into cluster 2. And let's see, we can do minimum of 75 receptions. There are no players in cluster 2 that fit that criteria. So what about the cluster 2 receptions of 50 in 2025? Still no criteria. Oh, nope, it refreshed. There are 5. And those would be Puka Nacua, Jamar Chase, Wan'Dale Robinson, Amon-Ra St. Brown, and Khalil Shakir, who had the most receptions in cluster 2, despite being a less notable receiver compared to the other 4. I mean, Wan'Dale might not be as notable, but he did just get a great contract with the Tennessee Titans. However, when you go over to cluster 1, you can see that there are 9 entries that fall into cluster 1. And then you got JSN, Nacua, Pickens, Chase, St. Brown, McMillan, Diggs, Sutton, and Olave, with Puka Nacua having the most receptions and JSN having the second most, with nobody else really even being close to those 2. And then if you want to go with all seasons and go with just cluster 1 with a minimum of 50 receptions, you can see that there are 107 players that fit that criteria. So we can go to the top 100. So if we sort by total yards, we can see that Brandon Cooks had the least total yards, and then we can see that Jamar Chase had the most total yards in this 5-year span based on the receptions in cluster 1. However, when we go to cluster 2, let's see who had the most in that cluster. So the most receiving yards in that cluster would be, actually the least would be Quez Watkins, and then the most would be Amon-Ra St. Brown. So, and then we can even sort it by team. So you can go see, okay, so who on the Ravens, because the Ravens are my favorite team, and fit into cluster 2 based on this criteria: Zay Flowers, Rashad Bateman, and Hollywood Brown. And then let's see in cluster 1 how many fit into the 50 receptions criteria. Just Zay Flowers and Rashad Bateman. So you can see how cluster 1 has a maximum of 98 yards, a minimum of -2, and then you can see how air yards versus receiving yards in cluster 2 fall a lot lower than in cluster 1. And then you can go and look at all of these, sort by any of these statistics, and then you can select any different K. So say if I wanted to make K a random number like 8 or 9, I could apply that to the data, and even though this data would be completely inaccurate and provide a pretty poor estimate, this is something that you can do with the Shiny app software. So hope you all enjoyed, and hope you all have a tremendous rest of your day. Thank you.